ठीक है, एलिवेटर जो होता है ना, लिफ्ट है. Suppose we consider a actual problem. Suppose we are going to design a lift, and that lift is how it is moved. It is moved with the help of a rope, steel rope, which is connected with the lift. Now the weight of the lift is given 1000 kg, okay. And the maximum acceleration which it can have is suppose 2 meter per second square. The maximum acceleration. Okay. Now we have steel wire. Then how much should be the minimum area of the wire so that it can be supported? It does not break. The wire does not break. ठीक है? अब एक चीज में दिया हुआ है, breaking stress will be given. The breaking stress is, suppose S we write 8 into 10 to the power 8 Newton per meter square. The breaking stress. So breaking stress is given, and its mass is given, and maximum acceleration which it will have is given. And one more thing, in practical cases, one more thing is considered, that is the safety factor. Because if the wire required is suppose 1 centimeter square cross section area, we are not going to use 1 centimeter square area in, if the required thickness is there. We will use more than that, because we cannot take a risk while making a lift. We have to keep some safety factor. So generally safety factor is in the order of 10, 8 like that. So 8 times of whatever is required. So safety factor is suppose 8. So safety factor means what? It means whatever tension you get, multiply that with 8 and then calculate. Are you getting? So 8 times of the actual tension which it can have, and then find the area. So what will be area? See, breaking stress is S. S into area will be the tension after applying the safety factor. We can write this breaking stress into area. So this much tension it can tolerate, and after applying the safety factor, ठीक है, safety factor अगर अप्लाई करेंगे, उल्टा लगा डिवाइड होगा ना यहाँ पर. ओके ठीक है, इसको ही रहने दो. ठीक है, suppose we got this tension. What we have to do is we have to consider we have to find the area, cross section area. So the area will be T by S. And tension कितना होगा बताओ? Tension यहाँ कितना होगा? 1000 kg है. Maximum acceleration is 2. So the maximum tension which can be produced here is mg, and if it is accelerated upward, the pseudo force ma max equal to tension. So tension maximum value will be how much? The maximum value of tension will be mg plus a max. So m is 1000, g is 10, a max is 2. So 12,000 Newton, that is the maximum force which we can have. Now multiply it with safety factor. We have, if it is 12,000 Newton, we will make the wire for larger force after multiplying. After multiplying, जो आएगा safety factor, it will be T max into eta. So 12,000 into 8 कितना हो गया? For this much Newton we have to design the wire. Area will be what? Breaking stress divided by this T dash divided by breaking stress. So 96 divided by 8 into 10 to the power 8. ठीक है? कितना होगा? 12 and here it is 12 into 10 to the power minus 5. Here 12 into 10 to the power minus 5. So this is in meter square unit. If we write in centimeter square, then it will be 1.2 centimeter square. So 1.2 centimeters, this much thick. 1 centimeter square, this much thick, approximately. So, okay, what is Poisson's ratio? If we have a wire and we stretch it by applying some force along the longitudinal direction, we apply the force, then the length of the wire increases, but the diameter of the wire will decrease, because if we increase the length, its thickness decreases. Generally the thickness will decrease. There are some material for which thickness may increase. There are some material for which thickness may increase. That happens because of their very special properties of having the crystal structure maintained. So due to that, there are some objects for which you may have increase in lateral dimensions also along with the longitudinal dimension, but generally it decreases. When you increase the length of wire, the thickness will decrease. So along the lateral direction there will be some strain produced along with the longitudinal direction. So the ratio of these two strains is called Poisson's ratio. So Poisson's ratio is defined as lateral strain by longitudinal strain. Okay. Lateral strain by longitudinal strain. So this is the definition. Minus sign, why we have put minus sign? Because if you increase this quantity decreases. So that's why minus sign is put. It is just to say it is a convention to consider it. Delta D by D. D is diameter. So fractional change in diameter divided by delta L by L. Fractional change in length. This is Poisson's ratio. And its value is fixed for a particular material. It is property of material. Poisson's ratio is property of material. Its value ranges from minus 0.5 to 1. Okay, minus 0.5 to 1. Why minus we are getting? Because for some material we have increase in the strain, increase in diameter even with the increase of length, but generally it is not there. It is only for some materials. Okay, this is the longitudinal strain. So what kind of question we can have from this? Suppose we have a wire. If you apply some force, pull the wire, then the question can be asked after giving the Poisson's ratio. The question can be asked, what will be the increase in area or decrease in area? Although the force along area was not given, the force was given along the length. So there will be some change in length, but that length can give the change in area also. The area will be found by using this diameter change. Okay, and Poisson's ratio will be given. The question, next question number 12 is based on this. Okay, so you have to solve 12 number. Solve the question number 12. देखो लिखा है copper wire of cross sectional length, area दिया हुआ है, is under tension of 20 Newton. Area is 0.01 centimeter square. Tension is 20 Newton. Find decrease in cross section area. Young's modulus is given 1.1 10 to the power 11. Poisson's ratio is given 0.32. ठीक है. What we have to find? Decrease in area. तो देखो, del A by A is area. Area क्या होगा? Area, how it is written? Area can be written as, in terms of radius, it can be written as pi r square. So delta A by A can be written as 2 times delta r by. So that is given in the hint itself. So this is the lateral strain. So now we will write Poisson's ratio equal to minus delta r by r divided by delta L by L, and delta r by r can be written in terms of delta A by A. So delta A by A by 2 delta L by L. So this is the Poisson's ratio. Now what we have to do is we have to find the delta L by L. So delta L by L will be how much? Divided by Poisson's ratio. So delta L by L, strain. So strain is how much? Strain is stress by Young's modulus. So stress, इसको डायरेक्टली लिखते हैं, स्ट्रेस कितना हो जाएगा? टेंशन बाय एरिया बाय Young's modulus. So this is the thing we have to do. Actually area is not required, it will get cancelled. ठीक है? And change in area only we need. This area is not required. Okay? So we T sigma 2 by y with minus sign. Minus sign indicates the decrease in area. Okay, the next concept now we are going to do is bulk modulus of elasticity. Yes, shear modulus of elasticity. Then we will do bulk modulus. ये कैसे हुआ? देखो, जो लोग पहले से क्लास कर रहे हैं उनको पता होगा, ठीक है? शुरू में मैंने बताया था कैसे ऐसा किया जाता है. If A is pi r square, differentiate this with respect to r, suppose r के रिस्पेक्ट में डिफरेंशिएट कर, किसी के भी रिस्पेक्ट में कर सकते हैं. What you will get? This. Now divide del A by A and take dr on the other side. Okay, if you divide A on one side, on other side also we have to divide the area. Area is same as pi r square. One side we have written A, other side we have written pi r square. Pi cancel, 1 r cancel. So dA by A equal to 2 times dr by r. This is the actual rule. This is the actual formula. But since changes are small in case of deformation or for this chapter itself, all the deformations are very small as compared to this total area. So we can write dA as delta A and dr as delta r. Okay? Okay. Next concept we will do shear modulus of elasticity. Shear modulus of elasticity. Other names for this is modulus of rigidity, or torsional modulus. All these are same. ठीक है? How it is defined? It is defined as shear stress by shear strain. So eta is shear stress by shear strain. So what was shear stress? Force per unit area, and shear strain was written in terms of theta, the angle twisted. Shear stress is force per unit area, where area should be parallel to the direction of force. If area is perpendicular, then it becomes the longitudinal stress. Area should be parallel to force. Now, if we have an object and we apply a force F, and the angle twisted is suppose 1 degree. We apply a force F equal to 100 Newton on an object like this, and it is twisted by 1 degree angle, and the area on which it is applied has value 8 centimeter square. What will be shear modulus of elasticity for this object? We have an object of some material, parallel to surface, a force 100 Newton is applied, and 1 degree of strain is developed. What an area is given. What will be the shear modulus of elasticity? What we should write here? We have to convert it into radians. We will not write in degree. Wherever if you have some angle written, you will always write in radians. Okay? So 1 degree is equal to how much radian?
5 by 180.
5 by 180. So this thing you have to do. So what you will have? 100 into 180 divided by 5, 8. कितना आ जाएगा? 18 by 8 pi 10 to the power 7 Newton per meter square. Unit is same as Young's modulus. कितना होगा? 8 या 24. 0.67 or approximately this much. Okay. Similarly, we have breaking stress, shear breaking stress, because if you consider in this direction, if you apply a force, the breaking stress will be different if you apply force in this direction. Generally, in this direction, you need to apply large amount of force, but in parallel direction, object breaks with smaller amount of force. So, shear breaking stress is also it is also an important quantity. So, लिख लो shear breaking stress. Shear breaking stress. So, what is shear breaking stress? The maximum amount of shear stress. The maximum amount of shear stress for which object does not break. Maximum amount of shear stress for which object does not break. Okay. So where it is important, in what cases? Suppose we have a sheet of metal and we want to make hole by punching it. Then we have to apply force parallel to the area. The area will be like this. The inner part of suppose we have a hole cut in the sheet, so that hole will be what? Cylindrical in shape, and the inner area will be the area required, and we have to apply the force parallel to that area, and we have to test for shear stress. If shear stress exceeds the breaking shear stress, then the hole will be made. Is it clear? Okay, so solve this question 13. Dekho, what is bulk modulus of elasticity? We had considered that there is a pressure that is also called pressure stress, pressure or pressure stress, which is generally due to the liquids or fluids, and there is something called volume strain. If you take the ratio of volume strain by pressure stress by volume strain, then it is called bulk modulus of elasticity. So bulk modulus is volume strain divided by pressure stress or pressure simply, and we put a minus sign here because with the increase of pressure volume decreases. So we write minus delta V by V.
सर स्ट्रेस ऊपर आएगा ना?
हाँ, ठीक है. Pressure stress divided by volume strain. देखो, what will be pressure stress? That is change of pressure, or if there is no pressure, then whatever pressure is applied, that will be pressure stress. And delta V by V with minus sign. ठीक है? In terms of calculus, in differential form, the same thing can be written as dP by dV. The rate of change of pressure with respect to volume into V. With minus sign is called bulk modulus of elasticity. Okay. So bulk modulus of elasticity will be given. You will be given the pressure, and then you have to find the corresponding change in volume. Then one more thing related to this is finding change in density, because once the volume will change, the density will also change. So how density is related to volume, that we will see. So this is for finding the volume directly. Now for density, we have to relate the volume with the density. So volume is mass per unit density, or density is mass per unit volume. So if we write for small changes in volume, because this change will be small, we have seen for this chapter elasticity all the changes are small. So for small changes we can write d rho equal to m by v square. Differentiating, after differentiating we can write like this. Okay? Or we can write m by v as 1 by rho. Okay? Sorry, rho. So d rho equal to minus rho by v dv, or we can write d rho by rho equal to minus dv by v. So dV by V is what? Fractional change in volume for very small changes, and this is fractional change in density. So this is the relation between these two, fractional change in density and volume. Since the changes are very small, we can write like this. This has came from differentiation. In differentiation we take infinitesimally small change, but for practical purpose, since this change is very small, we can write like this. Now if you relate this B with that thing, B is what? Minus V. So del V by V will be what? Del rho by rho. So we can write minus del rho by rho. So next we can write minus minus plus हो जाएगा. So this is the thing which we can write here. And यहाँ पर हम लिख सकते थे del B by V. देखो, compare these two equations. Fractional change in volume is equal to change of pressure divided by bulk modulus with minus sign. As you increase the pressure, fractional change of volume should decrease. ठीक है, should go on negative side. और इसमें उल्टा है, इसमें increase होगा. If you increase the pressure, fractional change in density will increase. If you increase the pressure, density will increase. And it is inversely proportional to bulk modulus. What is bulk modulus? How do you understand by bulk modulus? The modulus of elasticity is what? The tendency or the strength of restoring force which a material develops. So if bulk modulus is large, it means it can develop a large amount of restoring force by applying the pressure. So large amount of restoring force it can develop. Therefore it will get compressed by a small amount. So change in density will be small, or similarly change in volume will be small. That's why it is inversely proportional. Are you getting? It is directly proportional to pressure change, because as you increase pressure, volume will increase in more amount or change in more amount. And bulk modulus, it is inversely proportional, because bulk modulus is what? It is tendency to apply the restoring force against the applied forces. So it will apply larger restoring force and it will get deformed by less amount. ठीक है? Okay, one more term we define here, a compressibility. उसको भी लिख लो, compressibility. This is defined as 1 by bulk modulus. The higher bulk modulus we have for a material, the less compressible it is. Okay? Suppose for mercury, the bulk modulus is very large, then it can be compressed by a small amount only. For gases, bulk modulus is small and compressibility is large. Okay? So question number 13 and 14 are based on this. Solve question number 13 and 14.